The magnitude of a vector. Oh, I skipped ahead. Do we need to review Pythagorean theorem? Remember, C is the hypotenuse, the longest side across from the right angle. Magnitude is the length, size, norm, or intensity of the vector. We denote or give magnitude, and we'll usually use the single bar. But there we go. The formula for the magnitude of vector v is simply the square root of delta x squared plus delta y squared. That is Pythagorean theorem. A unit vector is a vector, any vector, having a magnitude of 1. To turn any vector, like v, into a unit vector, you divide by its own magnitude. This, if I take the magnitude of this vector, so the vector divided by its own magnitude, it'll always have a magnitude of 1. Okay, the same direction as vector v, but with a magnitude of 1. Example 4. Consider the following diagram. Find the magnitude of the following vectors, O to A. Magnitude of O to A is the root of, what's delta x? Negative 2 squared. Delta y, positive 2 squared. 2 root 2 is the exact answer. A to B. A to B is this one right here, not from the origin. So the magnitude of A to B is a delta x of 1 squared and delta y of negative 3 squared. That is root 10. B to C, obscured the letter a little bit. That's that one down there. B to C. The magnitude of B to C is the square root of delta x squared, which in this case is 4. And delta y squared is 2. That's 16 plus 4 is 22 root 5 units. Example 4. Example 5. Before we get to that, though, we have this. That means that the magnitude of vector A to G would be the square root of A squared plus B squared plus C squared. Or you could think of it as delta x squared plus delta y squared plus delta z squared. Three-dimensional Pythagorean theorem. Okay, so add that in. All right, find the magnitude of the following vectors, A to B. Each length is 10 centimeters. The magnitude of A to B is then just 10 centimeters. B to D, right here, it's a two-dimensional vector, if you like. It just goes across. It is 10 squared plus 10 squared. That is 10 root 2 centimeters. And B to H, it's this diagonal here. It's three-dimensional. So it'll be 10 squared plus 10 squared plus 10 squared, 10 root 3 centimeters. There we go. And we don't have time for example 6. That'll have to be on the next video.